So before we take up the topics for today, is there any question from last week's discussions?
Sir, I have a doubt about test. So
Yeah,
what
yeah,
will be the syllabus for the test? So it is on 10th, right?
yeah, that's right. So what we covered till this week will be the syllabus. That is till
Okay, sir.
tomorrow's class. Yeah.
Okay, okay, sir.
Okay, so if there is no other question, let us start. And in our last class, last week's classes rather, we talked about the structure of the blocks, and also we talked about transactions. And as we had seen that these transactions are sent from one user to another, okay, who in turn can use the bitcoins which were included as its input to send the bitcoins to the output. Okay. Now, after that, after having seen the structures of the blocks and the transactions, what we'll see next is that how basically the Bitcoin network is formed, and how we propagate the transactions throughout the network, and how they actually get into blocks, and then again the blocks are shared with all the nodes in the network. So that is what we are trying to see next. So what is Bitcoin P2P network? So we understand that it's an ad hoc network with random topology, and Bitcoin protocol runs on the TCP port 8333, and all the nodes which are representing users, they are treated equally. So there is no one who is more powerful than the others. And of course, new nodes can join anytime, and non-responding nodes are removed after a certain period, and they can join back later. So there is absolutely no one which is controlling this network, and remove, etc., are also done in an automated manner, meaning that any non-responding nodes automatically will be removed from the network. Now, you might wonder that what does it take for somebody to join the network? Suppose you want to join the network, right? So what is that you would need to do? So joining a Bitcoin P2P network, so this red node, okay, suppose it is your machine, and you want to join the Bitcoin network, and you are equally uh, competent to join the network. Anyone in this world can join. So what you all need to do is you have to install the appropriate app in your machine, be it in your laptop or a desktop. And then as you install it, it will also have a few other peer nodes identified for you. So it will start with a seed node, and what it will do is that this newly joined node will be contacting the seed node to get some list of addresses, and it gets that list of its peers. So it is a peer-to-peer network. So for this newly joined red node, it will get the addresses from a seed node as mentioned in the previous slide, and it will get a set of addresses for its peers. Okay, so let us not get confused with these addresses we are talking about with the public key addresses and so on. Okay, those are for carrying out the transactions, and these are for joining the network. Now, from these peer nodes, the newly joined nodes will get the most recent blockchain. Okay, so that means all the blocks. Typically, we can consider that it will have all the blocks starting from block number 0, and it gets all these this entire chain, and this application that he uses, that will show the blocks and the transactions very similar to what we had seen in the btc.com site or the bitcoin.com explorer site. So in my local machine also, I would be getting the list of blocks and new blocks getting added, and the set of transactions that are happening. So all these will now be available in my local machine. Okay, and if this block uh, does not do any transaction, suppose you join the network and you are not going to carry out any transaction, that means you are not going to receive any money to start with, any Bitcoin to start with, or you are not going to spend any Bitcoin, then also you could just be a passive network where you will be seeing all the transactions that are going on. Now, if you intend to start a transaction, okay, then you can now first, of course, that you first have to get some Bitcoin and then you will be able to spend it. Okay, so this is how we join a Bitcoin P2P network. And once you have joined, you have got your peers. Now you are in a position to carry out transactions. Okay. Now, as you can see that, or you might wonder that, so how the whole thing started. So somebody has to have some original, like the some way to get some Bitcoins in order to be able to spend it. So let me quickly show you that how it was there in the very first transaction. So I'll quickly take you to block number 0. Okay, so I am going to this one, and I go to this Bitcoin block height 0. Okay, and if I click on it, so you notice that this is the very first block in Bitcoin. I hope you are able to see my browser also. And if you see that in that one, 50 Bitcoins were actually generated. That was the very first transaction in which 50 Bitcoins were generated. Okay. And then from that, and there was nothing else that was there. So that was the first one. Now you can go to the next one and see that what was done with that, and next one and next one. And slowly you will see that something was used to spend the Bitcoin, or it could mine more, and slowly it started that, see that some amount was paid to another person. So this is the next one, and if you see that, then it is using this as input, like we talked about the script pub key. So this is the input, and then this was paid to another entity, which is this one. And you see here, you can see this amount, that is 1.699, this amount that was paid to this public key hash. Then if you click on this one, you can see where then it was further spent. Okay, it shows that it was spent to these two, this 1.699. It was split into these two, and of which actually, if you notice that this address that you have here is same as this address. And this is what I mentioned in our last class last week, that if I have this much of amount, I make a payment of this one to another public key address, and then what I do is that I take back the remaining one, except for whatever is the difference. Okay, that has to be paid in the form of fees. So if you see that in this particular transaction, from this as input, so if you see this is showing as the input, from this input, which had this 1.6991035 BTC, okay, actually 0.8 BTC stands for Bitcoin, is paid to this public address. Okay, I take back, so you see this address is same as this one, so whoever is this I, so that person takes back this 0.8988 whatever amount of Bitcoin, and you show that there is a fee of 0.000027716 BTC. So if you add these all up, okay, so this amount, okay, here, this amount which is here, okay, and this amount which is here, that will be this total of 1.6991018.5. And likewise, if you click on this one, you will see how this 0.8 Bitcoin was spent. Okay, so that 0.8 was here. So many such inputs were combined to make a payment, because this 0.80 is a small amount. So there are many inputs which are received and which were intended to make this payment of this one, okay, to two persons, and so on. So you could check things like this. So from originating transaction, one can keep adding new transactions and spending the amount of Bitcoin that was received from one or more inputs, and then giving it to one or more outputs. And if you have more input than what you intend to pay, the rest you have to pay it back to yourself. And the final differential will be the one that will be used for the transaction fee. So that is what you will do. So if you want to start a transaction, that means that you must always first be getting some Bitcoin paid to you, which then you can use as input to generate the outputs. And how to make use of it, we have seen in our discussion on scripts. Okay, so if we have this transaction, as we said, that Alice joins the Bitcoin network by opening her applet, so whatever application is there, and suppose she has some Bitcoin to spend, so Alice makes a transaction to Bob of say BTC10. So what Alice would do, as discussed before, would include the scripts with the transaction. So after that, then Alice will broadcast this transaction in the Bitcoin network. So everybody will be getting a copy of this transaction. Okay. So this is what we see here. So what we mean by this broadcasting it, so Alice is sending it to her peers. And if you remember that these were set up as her peers, so Alice is sending it to her peers. So everybody gets this transaction that Alice is paying to Bob BTC10. Okay. And so each of them will be validating the transaction. Now, what is meant by validating the transaction? If you remember from our discussion last week, that Alice would put her script sig where it would show that she has a public key, so that hash of that public key would match with the hash of the public key against which the payment was made. And also, Alice would be signing it with her private key, and then any node can apply her public key to verify that indeed it was signed by her. So that means that whatever public key whose hash Alice claimed to be her own and got the payment from the previous source, okay, so that all can be verified in this step of validating the transaction by any other node. So this node validates the transaction that this is correct, and once it is validated, then it will again, you see that it will send it to its peers. Okay, so you see that it has got this peers. It got it from Alice, did not send it back, but it sent it to all the 4 other peers. Okay, and of course this one had already got it previously directly from Alice, so this node knows that it has already seen the transaction. Okay, so of course that if you get it multiple times, then also it is always uh, detectable, because it will be all having the unique hashes. Okay, so that way these are all flooded in the network from one node to its peers, then to their peers, and so on. So everybody would be able to access the transactions that were carried out by Alice. Okay, now the transaction is valid with respect to current blockchain. So when would you relay the transaction? So as we showed here that we are validating the transaction, so we would see that the transaction is valid with the current blockchain. There is no conflict and no double spending. So how does it check for double spending? Essentially, every node can check what is the source of that Bitcoin that Alice is now spending. Okay, so Alice is sending to Bob these 10 Bitcoins. So from where did she get it? And it will show that Alice got it from another hash. Okay, and then if that had sufficient these 10 Bitcoins, okay, then Alice can spend it. Okay, and it can also check that with respect to the current blockchain, whether in another previous block already Alice had sent the same money to somebody else. Okay, so say Alice got it from Eve, and if that transaction in which Eve paid it to Alice, and now that same 10 Bitcoins Alice is sending to Bob, and she has not sent it to anybody else. So anyone who is validating will be able to check that, okay, so Alice is spending these 10 Bitcoins by sending it to Bob, and Alice got it from Eve. So the source transaction, and there is no other source, no other destination transaction where Alice used the same 10 Bitcoin from the same source that was Eve. Okay. So it means that it will not allow her, if she sends it to even another person, the same 10 Bitcoins, then it will get detected that Alice has spent it on Bob, and then now she is again trying to send it to somebody else. And so this double spending will get detected. Okay. And of course, the script would match with a pre-given set of whitelist scripts, and there is no unusual types of scripts, and there is no infinite loops, which might cause some issues that it will infinitely delay the processing and so on. So those basic checks are done, and that's why the language that we have seen, these are also made simple without any loops and so on. Okay. So, so that is what is done when somebody, some node is validating a particular transaction, and once it is done, it is sent out to the peers and so on, as we have already seen. Okay, so this is how we see it, that Alice has got this one, that Alice to Bob is A to B is BTC 10, and then C to D is BTC 20, and so on. So what will happen is that these are all going into a set of transaction pools. Those are there which are not yet included in any particular block. Okay, so these are the transactions that are there uh, in their transaction pools, their local transaction pools. And as and when a set of transactions will get included in a block, those will be removed from the transaction pool. As you can see here, that because of this completely asynchronous nature, that different nodes can have different views of the set of transactions. So as we see that some of them only got the A to B BTC 10, some got C to D BTC 20, some got A to B BTC 10 first, and then C to D BTC 20 next, and in the reverse order, and so on. So you get these in all possible different such sequences. Okay. Now, as I said, that if I am a node which is not doing anything, not doing any, making any attempt to mine, I'll just be seeing these transactions, okay, that are taking place, just like that BTC.com site. Now, if any node, okay, plans to mine the blocks, okay, then what it will need to do is that it will have to put a set of transactions, and then say if this first node, for example, on the top we see A to B BTC 10 and C to D BTC 20. Okay, if this one is trying to mine with these two transactions, okay, then in its pool it has got these in this particular order, A, B, and then C, D. While this one, when it is trying to mine a block, in it its pool of transactions we have C to D and then A to B. Okay, and similarly, this could have a completely different set of transactions, A to B and then E to F or so on. So it does not really matter, or we do not at all try to synchronize that all the blocks which are trying to mine the transactions, they will be actually, all the nodes that are trying to mine the transactions in a block, okay, so they are not necessarily going to have the same pool of transactions to be included in the block. Now, so the miners, mining nodes will be now trying to create blocks out of these transactions. Okay. So whatever set of transactions that node has got, that it will be trying to put in a particular block. Okay. So what then the miners are doing? So we have all these different miners. Okay. And what they are doing is that they are trying to include those transactions in a block, and each can have a different view of the set of transactions that they are trying to put in the block. So now at this point, just before they are trying, so all of them have got the immediate previous block. So all of them know that, say, the immediate previous block had a block number of, say, 100,000. So they know that they have got block number 100,000, and they are going to mine a new block which will be having a number of 100,001. Okay, so they are trying to do that, but again, all of them do not necessarily have the same set of transactions that they are trying to include in that block number 100,001. Okay, so as they are trying to put their respective set of transactions in a block, okay, one of them will be the first to come up with the proper nonce and be able to generate a block with the required level of difficulty, and that this miner, okay, could hit that nonce value and then has created block number 100,001. Okay. Also, you remember that I mentioned that from that pool of transactions that is there with this particular node which is doing the mining. So remember that this new block that he will create, that will have a size of up to 1 MB. Now there are different transactions of different sizes, okay, and these sizes are actually defined in terms of virtual bytes, and it can be shown that how that virtual number of virtual bytes can be computed based on number of inputs and outputs and so on. So that is fairly easy to calculate. And then if suppose it had got a total of 1,000 transactions in its pool, and from which it has to create the next block, that is 100,001th block, then say it can only add out of those 1,000 transactions maybe 100 transactions to create that block, because after that it will hit that 1 megabyte size. Then what happens is that the miner can choose to include those transactions that are going to give the miner more reward, okay, in terms of this transaction fee. And that is what I was mentioning in our last class, that the user who was creating the transaction can set how much transaction fee it is going to pay, and that unit typically is in units of satoshis per virtual byte. So virtual byte is the size of the transaction, and 1 satoshi is 10 raised to the power minus 8 Bitcoin. Okay, so it's like 10 nano Bitcoin, you can say. So now the miner might have chosen those 100 transactions which are likely to give him more satoshis per byte, okay, or per virtual byte. And that is what is at the discretion of that miner, because he knows that if he can be the first to mine the block, he will get the reward, the block reward, okay, and also the total transaction fee, okay. And that's why I might decide to choose only the ones which have higher transaction fees in terms of satoshis per virtual byte. And if somebody, a user, does not stick to the current standard of such transaction fee, it is likely that his transaction will be delayed while getting included in the block. So that is what we need to keep in mind. Now the miner who finally solved the puzzle generates a new block. Okay, so he was, for example, the first one to get the create the block, and then it will be flooded, just like the transactions were being flooded. So it will be flooded to its peers, okay, and it will also go to Alice, possibly, who first carried out that transaction and which assumed that got included in this block. So Alice would know that her payment got included in the block. And now while mining, of course, the miner has this list of validated transactions in his pool, transaction pool. And so these are, when these are going into the block, the blocks are then flooded. Then what will happen is that, I'm sorry. Now, when it goes to these peers, they can also check whether this is a valid block or not. Okay, because you have seen that we have carried out that simple exercise, that how to check whether that block hash is correct or not. Essentially, all these different nodes, they will also carry out the same process, so that they will check that whatever this guy is saying, that I have mined this block with these nonce and wants to add it as that 100,001th block. So these different nodes also will be able to check, and if they find that it is really true, so they will give up, even if they were trying to do the mining. Okay, as soon as they find somebody else has mined the next block, they will verify the block, and then they will also, it will also get added to their local chains, and then they will also be again sending it to their peers, and likewise all these blocks will now be flooded throughout the entire Bitcoin network. Okay, and as I said, that these guys will give up, and they will instead add it to their uh, blockchain, and they would like to do it as soon as possible, because at the moment they know that somebody has outsmarted them, there is no point trying to create the block. Rather, they will immediately try to mine the very next block. Okay, so they would add it to their blockchain and start mining from the pool of transactions, and they will also see that okay, this set of transactions are included in this 100,001th block, and those will be now removed from their pool of transactions which are yet to be mined. Okay, so those will be removed, and then the next attempt for mining 100,000 square block will be started by all of the different nodes who are trying to do the mining. Okay, so this is how we see that through that flooding, this will be actually generated. Now the question is that we took this example where these three were trying, and this one was the first to mine the block, and then it was sent. I'm sorry. Then it was flooded. Now there is a possibility that this one could mine the 100,001th block, and this one also mined the 100,001th block, and they did almost simultaneously. Okay, so by almost simultaneously, it means that before this miner knew about this having already been mined, or this knowing. Okay, so what will happen is that, so the nodes will keep getting as a next block both this block that has been mined by this miner and this block that has been mined by this miner. Okay, so that is what can happen if they mine the new block almost simultaneously or in a near identical time. If not, then of course there is no problem. So there is a unique next block that was mined and the others gave up, and that will be added to the blockchain. But this can potentially happen that two miners, before knowing each other's newest block, have also mined their blocks as the newest block. Okay. So in that case, what we can have is that we can have this situation where we have what is called a fork. Say block 1 was the immediately previous block. Okay. And then we have this this miner mined block 2 and this miner mined block 3, and then they started flooding. Okay, so this one started flooding, this one also started flooding, and then what will happen, every node will be getting both block 2 and block 3, okay, from their peers. Okay, now what they have to do is that they have to decide which one is the child block for block 1. Is it block 2 or is it block 3? So there are many ways of deciding it. The most common one is that if I get more number of block 2s from my peers, suppose this one got this, say this is maybe block 2, this is block 3, and it got block 2 from here and block 3 from here, and again block 2 from this peer node. Okay, then what will happen is that it will consider that block 2 is having is coming for more number of peers. Then I will treat block 2 as the next block. But in contrast, maybe another one got block 3 from here and also block 3 from here and block 2 from here only. So this node will treat that block 3 is the child node of block 1. Okay, and if there is a tie, there could be some tie breaking logic. Okay, that's not something. I mean, there are certain ways of breaking the tie, and let's not worry about that. So that is also a possibility. But otherwise, based on the majority, I will decide, or a node will decide which one it treats as the next block, that is the child of block 2. Now you see that if more number of nodes thought block 2 as the child of block 1, then what will happen is that when they are also mining, they will be actually removing from their pool of transactions only those transactions which are there in block 2. Others who are mining based on block 3 as the immediate previous transaction, they will remove the transactions from their pool which are there in block 3, and they will start trying to do the mining. Now you see that if more number of nodes are trying to do mining based on block 2, then it is possible that some of them are more likely to come up with this solution based on block 2, and then it is going to be, say, block 5 which got generated first, and then block 5 will be flooded, and so on. And as a result, what happens is slowly more number of nodes will tend to follow this part of the chain which has block 2 as the child of block 1 and block 5 as the child of block 2. And similarly, if at the level of block 5 there is another one which got mined simultaneously as block 4, but more people got block 5 as its immediate previous transaction, then they will be doing the mining based on the chain which has block 1, block 2, and block 5. Okay, and say block 7 got mined. So now because it is unique, so block 7, so this part of the chain, block 1, block 2, block 5, block 7, these become my accepted blockchain at this point. And then again, if there is simultaneous mining, there could be block 8 and block 9, and again block 9 will die out possibly and block 10 will stay. So this longest chain, so that is the whole point of propagating the block, is the only the longest chain will prevail. And as you can see that although these two miners mine block 2 and block 3 quote unquote simultaneously, okay, now because block 2 actually finally persists, okay, it is only the miner who mined block 2 will get the block reward. Okay, so and similarly for block 5, so those who mine block 3 or block 6 or block 4 or block 9, they will not get any reward. So this reward actually is not paid immediately that the miner mines a block, but rather it is paid only after that block got added as part of the long chain and the longest chain. And typically say after only 100 blocks, the actual money is paid to this miner. And the miner, of course, cannot use that money. That by money I mean that Bitcoin before it actually is confirmed that that block that was mined by it, that is block 2, is indeed part of the blockchain after another 100 blocks got added, and then only it would be released. Okay. So that is how the block propagates. But we see here that there is a possibility of this simultaneous mining, and this is what is called a fork. Now, what is to be kept in mind is that these are all happening because some of the nodes did not get the update that another node has mined the latest block and it is still mining. Okay, and as a result, only that another block can be mined simultaneously and a fork can get created. So this is what let us term it as the accidental forks. They occur very rarely. Okay, it is very unlikely that it would happen. This is because that it takes about 10 minutes to mine a block, and I think I will show this. So the latency for block propagation throughout the entire network is very small. Okay, so it is mean time is 12.6 seconds, and 95% of the nodes can see a newly mined block within 40 seconds. So while it is trying to mine a block, and that is expected to take on an average 10 minutes, okay, within 40 seconds of creation of a new block, every node would know that the latest block has already been added, and it will give up its mining steps, okay, that effort. So it is very unlikely that we will be having this type of forks happening accidentally. Okay, but there are certain times when there are some forks which are created intentionally. For example, say from the main Bitcoin chain, someone says that, oh, we want all the blocks to be of size 8 MB, okay, or 2 MB, not 1 MB. We don't want to stick to that, and there are certain reasons for it, and others do not agree, and they decide, oh, then let us form a group, and we diverge out of the main Bitcoin chain. So then they create what is called a hard fork, and like the hard fork was created for creating another type of cryptocurrency like Bitcoin Cash, and then they keep on working on that particular newly created fork. Okay, and also sometimes if you want software upgrades and so on, then sometimes we want to create some so-called soft forks, and then these are created. But these are more like intentional forks created in a planned way. And there will be more discussions on these during our lectures on consensus, that what can cause these forks to be created and how they are handled. Okay, but at this stage, what we understand is that how the transactions are grouped into blocks. they are mined and then how they are added to the existing chain. And in case of such forks happening accidentally, also finally um, the blocks which are there in the longest chain are accepted to be the valid blocks. Okay, and after a certain number of blocks are added, that means so many blocks have confirmed that block. Okay, then only the block reward is actually paid. Okay? And in fact, in the last several years, such types of accidental forks really did not occur. That which blocks to relay, already we have discussed that the transactions inside the block are valid. Okay, and we have checked along in a manner that we have seen before, that the hashes for the blocks are created correctly, and of course only the blocks that are included in the current longest chain that will be relayed. Okay, the forks are not relayed any further. So this is also what we have seen. Okay. So is there any question up to this?
Sir, when a node mines,
Yeah,
it gets some reward, right? So
right,
what
right.
is the source of that reward?
Okay, okay. Good. I am coming to that very soon. In one of the next slides, I am coming to it. Okay. Yeah, so I'll answer that very quickly. So you see that first of all, let us try to. So far, we have seen the technology part of it. Okay, and now what we'll do is that we'll touch upon this notion of Bitcoin as a currency. So that will answer your question. Okay, that. So what is this Bitcoin? So it is a so-called decentralized digital currency that enables instant payments to anyone, anywhere in the world in an anonymous manner. So there is no central authority, and it uses so-called peer-to-peer technology. And there are two broad operations. The transaction management part is what we have seen, transfer of Bitcoins. Okay. The other part is the money issuance. Okay, that is the monetary base, how it is regulated. Okay, so that answers the question. So first of all, that there is a bit of economics in it, and we are not going to go into details of it. Most uh, important reason for that is that we do not have that, at least I do not have that expertise to explain in terms of the economics. But what happens is that for any type of currency, if the supply is unlimited, then the value of that currency actually decreases. Okay? So it is important that supply of that currency is controlled. Okay, so it is important to understand that we should not be able to generate an infinite supply of bitcoins in the network. Okay, for example, if a lot of these cash is printed, Indian rupees, say 100 rupee notes are printed and distributed, then everybody will have a lot of cash, and as a result, what will happen that everything will become more costly. So there will be very high inflation. That means the value of that currency is coming down. What you got previously for 100 rupees, you need to spend 200 rupees for that. That means the value of that 100 rupee printed note has come down. So similarly here, for bitcoins also, that in order that we have a controlled supply, that is to be ensured, and that first of all means that maliciously generated currency is to be rejected. So just like in real currency, if there are counterfeit notes in the market, then that means there is an entire supply of these these invalid notes, but people will be getting those in their hand. They may start trying to spend, and if it is not detected, so that is as good as an infinite pool of that currency is coming into the market, and that will result in inflation. So of course the law and order people are trying to control that. Okay. So there are two aspects. One is there are no counterfeit such notes in the market, and also there is not an infinite valid source of notes. Like RBI should not be printing or minting currency and sending it to the or pushing it to the economy. Okay. So likewise here also, that there are two things. One is that bitcoins are generated during the mining. Each time a user discovers a new block, and that is going to answer the question. So these bitcoins is what is called is being minted. Okay, that is printing of that Bitcoin. The other is it is only a matter of transferring the Bitcoin from one user to another one. So this generation is done during the mining. And why is it done at the time of mining? Because that particular node has spent efforts and resources, and that's why that is called the reward. So you get the reward for doing something, that work that you have done. Okay, and that is called minting, and I mean like coming out with new coins or new notes which are pushed to the market. So this is how the bitcoins are actually generated. Okay, and after that, it is if one particular bitcoin, okay, is generated, then only that can be transferred from one user to the next and next and so on. Okay, and also in order that it is not devalued, so the supply of bitcoin in this entire network is controlled, and it is controlled in such a way that the rate of this block creation is adjusted every 2016 blocks to aim for a constant 2-week adjustment period. Means that that time to create a new block is kept at 10 minutes. Okay, and as we have discussed before, that the difficulty level is adjusted so that it will take 10 minutes even if the computational power is going up, and this is slightly adjusted from time to time in a 2-week period. And 2 week, you can easily see that it is 10 minutes and multiply by 2016, that will end up resulting in 2 weeks. Okay, and what is was planned, decided by Satoshi, is that the last Bitcoin will be mined in 2140, so 2140, and the total number of Bitcoins to be circulated or be in circulation will not exceed 21 million. So if you see the second bullet and first sub bullet, so 21 million. And what is done is that the number of bitcoins that are minted, the generated per block, it decreases geometrically with a 50% reduction for every 200,000 blocks, or approximately 4 years. Okay, so if you consider 200,000 blocks and multiply by 10 minutes, okay, and divided by whatever number of hours in a day and days in a year, you will see that it comes to 4 years. Okay, so the design of this Bitcoin network was done by Satoshi with that, keeping that in mind. Otherwise, if every time you create new blocks and you keep getting new bitcoins in the circulation, then the value of Bitcoin will be coming down. So in order to maintain its value, what is done is that it is ensured that the reward that you get, that is not going to be remain the same. Rather, it will be reducing every 4 years by 50%. Okay, so if we see this, okay, this example, that when the first Bitcoin was mined, okay, and I will also show it here so that you get an idea. So let me go to the first Bitcoin, okay, so that you see it here once again for your understanding. Is that you see this was mined by Satoshi, and you see that it has got a this reward of 50 Bitcoin. You can see it here. Okay, so this is written here also as block reward. Okay. Now, if we go back here, so it and it says that every 4 years it comes down. So roughly, it was in 28 this one that is at block number. So if you see 105,000, okay, then this block reward came down from 50. Sorry, I'm sorry. So in block number these 21 and then 4 zeros. Okay, so it is basically 210,000. The block reward, you see, from 50 it came to 25. Okay, so that also you can see. So if you see, for example, next block, that is block number 1, you see it also had 50. So if you see next block, you will see also it is having 50. Okay, but then if we have this block, okay, so 21 followed by 4 zeros. So if you see, search for this block, okay, and then if you see that, you will see that it has got a reward of 25. Okay, but if you see that immediate previous block here, okay, you will see that it has got a reward of 50, right? So that means that, and similarly, you can try it out. That so it became 12.5. Sorry, at 4.2 and then 4.0. So you'll see that it is less. And see, now always we are saying it is 6.25 because it was revised to this one sometime in 2020. So So it will remain so up to 2024. Okay, so that is how this is actually the circulation or pushing in of new bitcoins is controlled by this mechanism. Okay, now does that answer your question? I think Dhrumil was asking. Who was asking the question?
Yes, sir.
Okay. Okay. So good. So now let us see that what about sending the payment? We have seen that if Alice wants to send Bitcoin to Bob, Bob sends first his address to Alice, actually the hash of that, and Alice adds Bob's address and amounts of Bitcoin to transfer in the transaction. We have talked about it. Alice signs the transactions with a private key and announces a public key for signature verification. So all of these can now be verified, and that broadcasting of the transaction is there in the network for all to see, which we have already discussed. And double spending, of course, what it means, some of you had asked it in one of the previous classes. So if you see, if you consider cash, if you have a currency note of 100 rupees, you give it to the shopkeeper, you get the items. Now you cannot give that same 100 rupee note to somebody else, right? So for cash, there is no way you can do double spending. Okay, he can now spend it. For a centralized system for digital currency, so before Bitcoin, there were other digital currencies also, okay, which did not have these tangible notes printed on a paper or a coin. So these digital currencies were actually issued by banks, and every time you present that currency, which would have a unique value, it can be checked with the bank whether it is being double spent, or it is you are the owner, you have already spent it, and then you are trying to spend it again and you do not own it. That could be checked with the bank. Now, of course, that the same thing cannot be done in a completely decentralized network like Bitcoin. Like if Alice wants to send the same 50 Bitcoins to B and to C, okay, how is it checked? And that already actually we have discussed that whenever these transactions are being validated, it will be checked that whether Alice had already used that same Bitcoin to Bob once, and now is trying to send it to Eve once again. Okay, and then it will be checked that the same input that was used by Alice to send that 50 bitcoins to Bob is also now being used by Alice to send it to Eve, and then it will simply get detected. So it is going to prevent any form of such double spending. Okay, so there is no way that the double spending happens. In fact, that although people talk a lot about double spending in Bitcoin as it's a potential source for fraud or incorrect use or not an improper use of the Bitcoins that someone holds. It is not the double spending that actually matters. Rather, many a times that my Bitcoin is used by somebody else. That happens more because I do not protect my private key well. Okay, and somebody gets hold of my private key, and once somebody has that private key, they can actually make use of that corresponding public key and try to make use of that Bitcoin. Okay, so double spending is actually not a major problem for Bitcoin network. And of course, we have said Bitcoin is permissionless, and you can set up your account and use a wallet to join. And when you join, all you tell somebody to transfer money to you is your public key hash, and you could maintain a collection of such private key public key pairs, and for different cases you can ask to be paid to your different such public key hashes, so that even it is not easy to trace that, oh, someone is getting it into this particular address again and again, so this person has got so much of Bitcoins. So that also cannot be tracked, because you can ask different such your peers to pay to your different such public key hashes. Okay? So it is important that this Bitcoin address is used for transaction, not username or identity, not your IP address and so on. Okay, so it is going to ensure anonymity. Okay, and this already I have sent that Bitcoin address is the hashing of the is a public key which is generated using ECDSA, and then hash of that is used. Okay, and also remember that it is a private key that needs to be generated, and once the private key is there, the public key can always be computed from that on the fly also. So that is what we can see. So if we sum it all up to this, that Bitcoins really do not exist in a tangible or electronic object. Okay, there is nothing like an electronic object. And of course, there is no coin. You see the logo, but you cannot actually buy a Bitcoin. So there were a few minted actually a long time back, but actually those are not minted. So you cannot actually own a coin or something. Okay? So owning a Bitcoin means that you have access to a key pair. That is all it means to own a Bitcoin, which has this public key to which somebody else had sent that Bitcoin. Okay, and a matching private key that gives you the authority to send this Bitcoin that you have received to another address. Okay, so that is all it means to own a Bitcoin. Okay, so there is nothing else to it. That is what is to sum it all up. And if you lose your private key, then you lose the corresponding Bitcoin. So it is estimated that maybe 1 million Bitcoin is lost because people either lost their private keys or they died and they could not share their private keys with somebody else. Okay, so so it is all about ensuring that you keep your private key secret. Now you think that if it is there, and then is it that you are saying that you are going to make this transfer of your Bitcoin that you own to another party? Okay, so that means that why would you actually pay that Bitcoin to another party? Because you must have got some service. So in real life, actual real world, you might have got some service from that person. So Bob provided some service to Alice, and Alice is now paying instead of using say Indian rupees, paying using Bitcoin. So that is what we have seen, that how Alice would transfer money to Bob. Okay, and all that you need is this set of private key, public key pairs. So it is important that you store the private key somewhere. And how do you store? It should be safely stored. It could be in your desktop. It could be on the web somewhere you keep. So it is part of your maybe wallet that is that you have installed as part of the Bitcoin software. You could also have it in your mobile phone. Why mobile phone? Because you see that suppose you want to make payment with your Bitcoin as you go to a store. Okay, so then if it is in your desktop or in your cloud, you may not be able to use it. So what you can do is that wallet also you can store in your mobile phone, and then you could actually go to a store. Okay, and there you say you buy something from tech market, something worth 100 rupees, and you convert it into Bitcoin. And just like you make your payment through your Paytm app or Google Pay and so on, what you could do is that person will have a QR code that will be the hash of his public key. So that orange juice stall where you make the payment, okay, that guy will have a QR code which will be the hash of his public key, and say that, oh, you pay using your Bitcoin. So what you will do is that you will scan that, you got the public key hash, and now you use from your wallet some Bitcoins to pay to that public key hash. Okay. Now then it would mean that your private key must be stored in your mobile, right? So that could be a little tricky, because if somehow someone hacks your mobile, will get hold of your private key. So often what is done, a special hardware attachment is used where your private key will be stored. Okay. Now, of course, that hardware attachment cannot work with your mobile phone. It might work with your desktop or laptop. So what you could even do is that you could take a QR code printout of your private key, okay, and you make sure that you are not losing that piece of paper. So as you go to the juice stall, you scan the QR code of that stall owner to get his hashed public key. Now what you do is that in your using your app, your mobile phone, you scan the QR code printed on your piece of paper that contains your private key, and using that you now carry out the transaction. As long as you are not losing that piece of paper, it's safely there in your wallet, you see your transactions will be safe. So that is what it all means. Or if you go to Big Bazaar and you want to pay, you could just simply pay it in a same manner. So they will say, oh, this is your total, and this is so much in rupees, so much in Bitcoin, and you could make the payment like that. But of course, keep in mind that many countries do not allow such payments to be done using Bitcoins. Okay, so that is, of course, maybe not legal in some countries. Okay, so if it is legal, you could always pay like that. And now, finally, the point that we said that we'll not discuss much about trading and all, and we are not discussing it, just but to make sure that you understand this term Bitcoin exchange. Okay, so so that at the end of the course also you really would not be in the dark. So that is different from what we have said so far about actually payment using Bitcoin. And so this is about trading Bitcoin as a commodity. Okay, just like one can trade gold and or it could be foreign currency, or it could be shares and so on. So what you have is these exchanges, just as you have stock exchange, you have Bitcoin exchanges, and these names might be familiar with you. You get so many ads in TV and all Vazirex and so on. So what you do is that you register with them. They will verify your KYC documents, okay, and then you pay. So they say that you can start with as small as 100 rupees or so that is there in your account. And now what they will do is that they will maintain your account in say real currency, okay, and then you can say, okay, if the Bitcoin price, and the Bitcoin price, of course, as you understand that every day that is varying, and if you go to this btc.com site also, you could see all the time that what is going on, okay. So the very first yeah, so you can see the Bitcoin price, right, that it is varying. So that is basically that is being traded, okay. So what happens is that you could say that, oh, if say Bitcoin price go below say 5,000 rupees, then I will buy so many, okay. So I'll buy 5 Bitcoins. Or if it is goes above 10,000, then I will sell 3 Bitcoins and so on. So that is what you can set up with your account with these exchanges, okay. And you are now buying and selling. You can set those, and then you make some profit. And suppose, so they will maintain your balance in that Bitcoin account and your balance in rupee account. So initially you paid 100, then you paid maybe 1,000 and so on. That is your rupee account. And as you are buying Bitcoin, so what happens is that your rupee account will deplete and Bitcoin account will go up. And if you sell, you will get some money back in your rupee account. And then if you want that, you may say, oh, transfer so much money. So I have got 1,000 rupees in my rupee account. So I want to get that money out. And what you simply do is that this can be transferred either to your debit card or credit card or your bank account and so on. So the exchanges actually provide that features. But if you do that, what might happen is that you will end up of course, the exchange would know about you, the identity, how much money you are making, and all those things. So sometimes it is possible that this payout can be done not to your particular account or debit or credit card, but anonymous prepaid cards are there. So that is like ATM cards with prepaid amount loaded. So 1,000 rupees you get it, and no names is there, and it can be spent anonymously also. But even then, this centralized exchange means that in some sense that some people know about you, and because they will verify your KYC documents, and the whole point of having everything decentralized, that is no longer there. So that's why there are some notions of decentralized exchanges are there, but I mean that is running on the the Bitcoin network itself. Okay, so they act like decentralized exchanges, or I could have some other node act on my behalf as my exchange. Okay, but not like a centralized exchange which is controlled by other parties. Okay, one of the Bitcoin nodes itself could act as exchange, and they could have decentralized, and they can cooperate with each other and so on. So there are more ways of creating such types of exchanges for Bitcoin trading. Okay, so that is what I intended to cover, and takes us to the end of this part of our lectures. If there is any question, I will be glad to answer. Sorry, I overshot a bit, but thought of completing it so that in our tomorrow's class we take up a new topic.
Sir, it is guaranteed that no double spending would occur, but can it not happen that a node will just like a miner will just intentionally leave out some transaction, and that block actually gets inserted in the longest chain, so it is accepted by all. So the
No, if you
transaction.
leave out any transaction, so that transaction is not valid anyway. Oh, so that is a good point. Okay, so let me also tell you this, that see this uh, I said something. One is that block reward you get, okay, only when there are another 100 blocks that were added to it. Similarly, a transaction also is considered to be valid only after it has been confirmed by another, say, roughly about 6 blocks. Okay, so if this transaction has not been included here, that the receiver does not get that amount. Okay, so when would you do double spending? Suppose you got so A got some service from B and C, and A only has 10 Bitcoin, and also has to pay to B that 10 Bitcoin for the service, and also 10 Bitcoins to C for the service A received, right? So when is that going to happen? It is only when such a situation or a need would arise. Okay, so that means that A's transaction of paying to B 10 Bitcoins and A's transaction of paying to C 10 Bitcoins, only when it has been confirmed in some blocks, and in the first block, I mean in one of the blocks, and then that block got added in another 6 blocks as part of the chain, they can only actually B or C can now make use of that 10 Bitcoins. Okay, and till the time that B or C have not got that, so they will not maybe say that service they will give only after they have got the payment. Okay, so B and C will not treat that A has made the payment till actually the transaction that shows A is making 10 Bitcoins to B is confirmed in a block and further confirmed in another 6 blocks, and similarly for C. So that is what is not going to happen, unless of course there is this 51% attack, that 51% of the power is in the hands of a pool of these miners who can put whatever they want and say that I have confirmed and those things in this, but in some blocks and further 6 blocks and so on. But it is very unlikely that these will be able to join hands and hit that 51% figure. And also it is important that what they will gain out of it, unless it's a matter of really very large amount of Bitcoins, it may not make sense to actually do it, and it gets always detected otherwise, unless it is 51% computing power is with them. Okay, so the essential part is that everybody stands to gain if everybody sticks to the rules. Okay, by deviating from the rules, typically it is very unlikely that you will gain out of it. That's why everybody would be sticking to the rules. I am stopping the